That's right. All right, little direct variation. Now let's explain how direct variation works. How many of you bought pumpkins yesterday? Or this Halloweeny season? Yeah? All right, well, direct variation works like this. If you buy pumpkins, usually you buy them per pound, right? You go to the store, you buy your pumpkin, and they go, do you want a pumpkin? And you're like, yeah, and then you get a pumpkin and it has cost per pound. If you don't buy a pumpkin, do they charge you? No, usually not, unless you go to like the pumpkin patch and there's a fee to get in, but we'll ignore that. Let's say you're buying it at the store or something, okay? So you go there, and if you don't buy a pumpkin, they don't charge you. Let's say the pumpkin costs 70 cents per pound. Well, if it costs 70 cents per pound, that's expensive pumpkin, by the way. But let's just go with it. Maybe we'll do 20 cents. That makes me feel better, like we're getting a better deal. Okay? Let's say my pumpkin costs 20 cents per pound. If it's 20 cents per pound, that's going to equal my total cost, right? This is a direct variation. Why is that a direct variation? Because they're not charging you an initial fee. In other words, that piece at the end is? It's zero. So if you're not adding anything to your cost to your rate, you don't add anything or subtract anything from your rate, then it's a direct variation. When you graph a direct variation actually goes through the origin of a graph. Okay, it goes through 0, 0. It's the one thing you guys deal with the most in life. Right? If you buy your pumpkin, if you buy 0 pounds, you pay $0. You buy 1 pound, you pay, well, in this case, you'd pay 20 cents. So if we're graphing pounds and cost, your total cost is 20 cents. You buy 2 pounds, you're now up to 40 cents. So it relates directly to the number of pounds you buy. There's no other fee involved there. That's a direct variation. How many plan on driving here soon? Like getting your license in the next couple of years? Scares me. But, I mean, most of you are pretty good drivers, but some of these people that I see walking around, and I saw a ninja walking to school today and stuff, and a hockey player, and so those kind of things scare me. They're driving their cars in those outfits and stuff. That'd be scary. Okay, think they're ninja style in their car. How many are going to have to pay for your own gas? Okay, now if you go to the gas station, now some gas stations like Chevron, they have like little TVs at the gas, like so while you're pumping gas, pumping gas, you can watch TV. Seriously. Anyone seen those yet? Yeah, go to Chevron. You'd be like, hey, hold on, I want to see this part of the show. Okay, you'd be sitting there for a while. It's like a little TV, but you can't. Yeah, big line. You got to watch the end of the show before you leave. Okay, but if you go to the gas station and you're like, yeah, you know what? I don't think I'm going to buy any gas today. Okay, you just drive in and check out what's on TV and then you leave. Kind of lame and boring. It's probably not a good date for guys. Not a good idea. Okay, kind of lame and boring. But if you go to the gas station, just check out what's on TV and you leave, do they charge you? No, don't charge you. And then right now, gas is about $3 a gallon. If you buy 1 gallon, you're going to pay $3. You buy 2 gallons, you're going to pay $6. Okay? So that's a direct variation because you're not charged an initial fee. Anytime you buy something and you're not charged that initial fee, you're paying a direct variation. Yeah?
So like if you go to the store and then you get charged tax, that would be a constant variation?
And it's not, because you're still at 0. They're not going to charge you tax to just walk in the store. Yeah, I mean, maybe in the future they will. So you come in our store, you're going to pay a tax. They need to make some revenue for the state. But they don't do that yet. So tax would be part of your direct variation. So maybe the shirt you buy at the store costs, I don't know, $20 with tax, after tax. That's a direct variation. You calculate the tax in with the overall cost. Okay? When would be a situation when you wouldn't have a direct variation? Maybe when would you have a situation where your picture doesn't look like it's going through the origin? Maybe it starts up here at 2, and then you have a fee per. Dude. Cool. Yeah, it's like if you have to pay an entrance fee. So maybe for the pumpkin that you went and bought, maybe they charge you $2 to get in, right? Because it's such a cool place. And they scare you and make you feel scared the whole time. But you get to pay $2 for it, okay? You get to be $2 to be scared, all right? And then you get to buy a pumpkin, which will cost you, depending on the pounds. Okay, so maybe there's an entrance fee. That's a non-direct variation. That's where you're adding something. So maybe our cost of our pumpkin now went from 20 cents per pound plus a $2 fee. Okay, so this is not a direct variation. Notice the difference. Okay. All right, a few other things we need to know. Direct variation, special linear equation where the y-intercept is 0. That means you don't add or subtract anything. It's but plus 0 back there. Okay, constant of variation is just our slope. So we started out with the name slope. Then yesterday we changed it to rate of change, and today we're calling it constant of variation. All of those things represent the same number. So we had slope, we had rate, and we have constant of variation now. They all mean the same thing. And some of you just go, yeah, it's the thing attached to the x, when in slope-intercept form, which we'll talk about later. But okay? All right, well, let's try some of these. How many think you know what a direct variation looks like? Okay. I want you to tell your neighbor, just right now, it says, is each equation a direct variation? That's the first question we're going to answer. So right now, I want us to answer that. 1, 2, 3, 4, and 11. Go for it. You get about 3 or 4 minutes on it. I'm going to pause you. We're going to go straight. The most votes here, okay? So majority wins. Number 1, who says yes, direct variation? Who says no? You got to vote. Yes? Okay. Why is it yes? That is true. Why is it yes? Katie?
Because it doesn't have it doesn't have anything after the x.
Good. It doesn't have anything after the x. That's a good reason. Okay. The y-intercept is 0. Okay. Y-intercept is 0. All right. The thing after the x. Now we haven't talked about that, but I'm just trying to get you used to it. That's not the answer. The answer is yes, and then we'll come to the other part here in a minute. Number 2. Who says yes? Who says no? Okay. Now this doesn't have y by itself yet, does it? Yeah. How do you know it's no? Cool. Okay, so get y by itself. What's the first thing I do to get y by itself? TT? What's that? We don't want to move the y yet. Yeah. Yeah, let's move the x's. So we'll bring that whole chunk over. So the last thing we do, and this is why we did yesterday's assignment. So they get a little easier in terms of it. The last thing we do is we break apart the y and 4. Now notice the thing in between y and 4 is what? Multiply. How do you do undo multiply? Divide. And we got to divide everything by that. Since whenever you have a plus or a minus, you've got to divide each part. Well, now when I do that, that gives me y. It gives me negative 7/4 x. And it gives me plus 2. How many say, yep, direct variation? Oh, that's so, you guys got to tell me if it's that blurry. That's really bad. How many say, no, not direct variation? Dude, that's really bad. There we go. That's better. Okay, who says no? Who says yes? Jaden, why is it no?
Because
Oh, two
y
Jaden.
is not
Yeah, it's because this piece back here. Is that what you meant? Yeah, the thing afterwards is not 0. So we're adding in there. Jaden, is that what you're going to say too? Yeah, okay, good. So this one is no. All right. Number 3, who says yes? Who says no? All right, who has not got there yet? Okay, let's go. 3, 4, and 11. Let you guys finish those. The strategy is to make sure that you put them or get y by itself first, okay? What's the first thing I do on number 3 to get y by itself? Annalise?
We
Subtract
subtract 3x.
3x. Well done. Just like we were doing yesterday, right? Okay, we move that over. That gives me 0, so I'm left with negative y equals negative 3x, and we don't need to do anything with the 0. Now what? This negative means I have what in front of it? Yeah, 1. Negative 1. So I'm multiplying by negative 1, so how do I undo that? Divide by negative 1. So we get y is equal to 3x. Direct variation, who says yes? Who says no? Okay. Yes, it is. Okay. There's nothing at the back part here. So it's a direct variation. Okay. Let's stay with those 3 right there for now. All right? On those 3, we have 2 that are direct variations. Number 1, number 3, and then there's one that isn't. If it is, so those 2 that are, find the constant of variation. I want you to tell your neighbor the constant of the variation on number 1 and 3. Okay, what's the constant of variation on number 1? Someone new? Oh, come on, man. Yeah,
For number 1,
yeah.
2/3.
2/3. Who agrees? Yes, constant's just the slope. So the constant of variation is 2/3. You can just, if you want, you could just put COV, constant of variation equals 2/3. That would be fine. It's like our slope, right? Number 3, what's constant of variation? Chelsea? 3. We won't include the x though, okay? So just the 3. So the constant of variation equals 3. All right. Okay. Any questions there? All right, here's what we're going to do. We're going to spend a few minutes working on a few. All right. So, taking a look at your assignment right now, that side, we're going to be working through it, but we're going to go ahead and cross out those right there. Okay? So right now, I want you working on these 9 problems up in there, just kind of practicing that skill. Okay? I'll give you guys about, I don't know, 5 minutes of work time before we move on to the next part. You can get as far as you can. We're going to go ahead and jump into the next piece here. All right, so finding a missing value of a direct variation. So this one says, suppose that the ordered pairs in an exercise are for the same direct variation, find a missing value. Okay, well let's think of it like this. First, if I have a direct variation, you don't have to copy this down if you don't want, but right now I'm just going to draw an xy, and I'm going to plot the ordered pair 2, 1. That's the one I know for sure. Okay? Everyone with me? All right, so we're going to call that point A. Okay? So I call it point A there. And then I need to figure out where 6, 4, 5, 6. So in 6, I need to figure out where to go on Y. I'm assuming it's going to go upward. Maybe not. We'll find out, right? Any ideas? Ooh, this one's B. It'd be nice if we knew the slope, right? Because then we could figure out where to go. What do you know about a direct variation, though? Boy, brainstorm. You get 30 seconds. Quickly, what do you know? Look back to your very first part of the notes that I gave you today. What do you know about a graph and a direct variation?
The y-intercept's at 0.
Huh?
The y-intercept's at 0.
Oh, that's good. Yeah, I like that. Okay, we shared our thoughts. Ryan, what did you say?
The y-intercept's at 0.
Dude, the y-intercept's at 0. How many came up with that one? Yeah, how does that help us? Bobby?
No, you can like use a ruler to see where it goes, connect the 0 and the point dot you already have.
Good, you could use a ruler. Can we figure out the slope now? Yeah, what's the slope? How much do we rise? 1. We run? 2. Dude, where did that 1 and 2 come from? Yeah, dude, that's this coordinate. Right? Y over x is our slope. 1 over 2. That's just y over x. Change in y over change in x. Well, if that's 1 over 2, then this one's probably the same thing. Right? It's y over x. Y over 6. Well, if 1/2 has to equal y over 6, what's y have to be? Yeah? Is he right? Yeah. Right? We'd have to replace the y with a 3. 3/6 is 1/2. Is that accurate? Well, we could actually test it. 1, so we got 6, and we go up to 3, and hey, looks like we'd fall right in line there. Okay? Now, the point isn't to have to draw the graph, but the point is that these are proportional. Okay? So this has to be the same as that, and it's because it goes through 0, 0. How many think you got that? This was always going to be, y over x always going to be your slope in a direct variation. So calculating slope with direct variation is great. You just say, well, I know the slope of this one is. Tell your neighbor the slope of this one. Okay, how many has it? Okay, what do we got? Someone that hasn't participated yet. Come on, man. No one? Oh, Annalise already participated. I need someone new today. Slope is change in y over change in x. I have a bunch of you that would participate, but I need someone new. Bobby.
3 over 6.
3 over 6. Okay, how'd you get that?
It's the same as number 19 except the x and y was switched.
Okay, same as 19 except for the x and y is just switched. So we have change in y over change in x. So based on this, JC, what's the change? What's the y? So which one of these is my y value? Huh? Yeah, 1. Marie, what's the x value? 2. So y over x, right? Change in y over change in x. Okay, the reason how we can get that is because we know that our slope's at 0, 0, or our one of points at 0, 0. We go over or up 1 and over 2. Well, as Bobby pointed out, hey, this is just the same problems. Like now that this is 3, it means this one has to be 6. Okay? Yeah.
Can't you kind of just like, with the starting problem, you have both the x and the y? Can't like, I don't know how to explain it.
Why don't we try one? I want you guys to take a look at 13 on your paper. Okay? Number 13, I want you to work with your partner. Try to solve that one. It's a bit different now. I'm not going to tell you, I'm not going to call you, I just want to know who has what they think is the answer. Okay. All right, so this one is 2 over 3, right? Y over x equals y over x. Okay, so our y over our x equals our y over our x. And so this y is y, and this x is 6. So as Brendan was pointing out, look, you could just multiply that by 2. And so I could just multiply this by 2, and I get, what's y? 4. So y equals 4. How many had y equals 4? Well done, man. So sometimes it's not as easy as that, right? I mean, sometimes you may have to do some cross-multiplying. All right, so the other way to solve this, you could have said 6 times 2 is 12, and 3 times y is 3y. So if the numbers don't go in nice and pretty like that, so just cross-multiply them. That means divide by 3, y is still 4. Okay. Any questions there? Ayla, you got that? Kind of hard to see because of the... You got it? Okay. All right, I'm going to let you guys cross out these two. Okay? We've got to do our last piece here together as a class, otherwise we'll run out of time today.
Can you do those for extra credit?
Yeah, you can do them for extra credit always, yeah. Okay, moving on. I want you to take a look at the back. You notice the back, there are 4 graphs there, okay? We're going to have those 4 graphs. You get to skip you get to skip this problem right here, number 13. We're going to do 14. You're going to do 14. It's kind of like what we talked about at the beginning of class. But I want to talk about graphs. It says for each, or tables, excuse me. For each table, tell whether y varies directly with x. If it does, write a function rule for the relationship. Okay, well, so here's the same thing. And here's the test you have to do. Okay? If something varies directly, what it does is it means that our constant will always be y over x. Just like we talked about change in y over change in x in our previous set when we have an ordered pair, you've got to look at change in y over change in x. Okay? So y over x. So always remember, if it's a direct variation, we can assume that one coordinate is always 0, 0. Everyone with me? Okay? So if that's the case, we know that 2 divided by 4, so y over x, so you're going to make a new column that says y over x. It's a direct variation. We should just be able to do 2 over 4, and that better be equal to this one, y over x, and this one, y over x. Are all those the same thing? Yeah, tell your neighbors if those are all the same thing, and if they are, what are they? Okay, are they the same thing?
Yes.
Yes, what are they? Go ahead.
1/2.
Yeah, how many figured out they're all 1/2? Well, that 1/2 happens to be our constant of variation. So our equation is just y equals 1/2 x. We take that, we put it into our direct variation equation. That becomes our constant. Okay? All right, I want you guys to try number 26. See if they vary directly. Is y over x the same in all of them? If it is, write your function. All right, so y over x. So we got y over x is, well, we're just going to go y over x. So -2 over -3, 2 over 3, and 6 over 9, all equal 2/3. So Audrey, what's our function? Y equals 2/3 times x. Don't forget the y and the x. Here we got it. How about number 16, direct variation? 6 over 2. 13.5 over 5, 21 over 8. This one doesn't even reduce. This one becomes 3. Nope. Can't do anything.